Before we get into working with the standard form of the circle and parabola equations, I want to talk about what's called the locus definition for each of these shapes. So as we go along, we'll see this locus definition come up. And what the locus definition tells us is how we geometrically construct these different shapes. The word locus itself really just means the location. So when we talk about the locus of all points equidistant from a single point, what we mean is the location of all the points that are the same distance from a single point. So if my single point is fixed point like this, the center of the circle, each of these points on the circle itself is the same distance away from this point, a constant distance away. So when you've drawn circles using compasses before, you know that that's how that works. You put one point into the paper, and then the compass holds the pencil at a fixed distance away, and as you move it around, it stays that same distance and constructs a circle. I like this little clip right here because this person is actually using two pencils as a compass, but turning the paper instead of turning the compass, which allows you to hold the pencils nice and still, put one pencil into the paper, turn the paper to make a circle. Pretty cool. Okay, so this is what we call standard form for a circle. And the equation right here in standard form tells us three things about the circle. It tells us this value h, it tells us this value k, and it tells us this value r. And it turns out that h is the x-coordinate of the center of the circle, k is the y-coordinate of the center of the circle, and r is the radius of the circle. Now you want to be careful about a couple things here. When you see standard form and it looks like this, you have a circle. The number on this side, you have to take the square root because this is a squared number. So the square root of this side is actually the radius. Also notice that the standard form has x minus a number and y minus a number. That means that if h is a positive number, we're going to have x minus h here. So in other words, if this were 3, for example, we would have x minus 3. So when you see x minus 3, you have to think positive 3 for the actual x-coordinate. Same thing over here. If k were negative 5, we would have y minus negative 5, which would actually be y plus 5. So when you see y plus a number, your k value should be negative. So let's go back to the completing the square example we did in the previous video. We came up with this for our first example, and let's see how this relates to the standard form. So what we see is that we have x minus h squared plus y minus k squared equals r squared. And now we can just match everything up pretty nicely. It looks like in this case we have h is equal to 2. We have y plus 3, which means k is actually negative 3. And r squared is equal to 4, which means r is equal to 2. So this circle has a center at 2, negative 3, and a radius of r is equal to 2. So that's actually enough information to graph this. So let's go ahead and see how we're going to make a graph of a circle here. We're going to put our center at 2, negative 3, and then we're going to have a radius of 2. And on a grid like this, if you're sketching a circle, the easiest thing to do, I think, is to start at your center and put points on your radius left and right along the grid. So 2 to the right, 2 to the left, 2 up, and 2 down. And then from there, it's a matter of just kind of sketching in something that kind of vaguely resembles a circle. Okay, so that's not a very good circle, but it gets the point across, and it's certainly good enough for purposes of what we're doing here. If you want a good circle, use a computer graphing utility of some sort. You get a very nice picture here. You can compare my not so good picture with something that's pretty close to perfect. Let's take a look at that second example. All right, in this case we had x minus h squared plus y minus k squared equals r squared. And remember, we changed y squared to y plus 0 squared. And so hopefully you can see that in this case h is equal to 4. Nope, h is equal to negative 4, isn't it? Because this is positive. X minus negative 4 gives us x plus 4. And then k is 0. To get from y minus k to y plus 0 is basically just k equals 0. R squared is 36, therefore r must be 6. So we have a center for this circle at negative 4, 0, and we have a radius for this circle at, or r of, I should say, radius of r equals 6. Let's go ahead and graph that one. We're going to be at negative 1, 2, 3, 4, and 0, so that's right on the x-axis here. And we'll go ahead and get a radius of 6, so we'll go 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. And again, make a very not so good circle. Actually, that's not too bad. And there's my beautiful circle. There's an even beautifuler one made by a computer.